All right. Okay, so we'll try to keep the excitation going, but I think it's going to be a tough. So my name is Michael Garcia. I'm a senior technical program manager in the AWS IoT team. And today we are going to talk about IoT and especially what it means IoT at NASA JPL. And for that, we have to welcome later on stage Mick, that you just saw, and Tom as well, who is the CTO. So we are going to present you a few patterns that we see customers using all the time. And this is meant to be a section in order for you to be, for everyone to be on the same page. Because every of those patterns, Mick and Tom will present either a video or a demo on how to use them. And then at the end, we'll have a question. I'm sure you will have plenty for Mick and Tom as well. And I actually have one question for you now. It's an easy one. Who has a smartphone? Raise your hands. I should see everyone raising hand. We are in 2016. OK, good. Take them out, because in a few minutes, we will be using them for a demonstration. So go ahead, take them out, and I will make you go to a URL in just a few minutes. So the first pattern we wanted to talk to you about is all of you know AWS IoT, our managed service that will enable you to connect billions of objects securely. And you might have seen in the Andy Jassy's keynote yesterday that we introduced AWS Greengrass. And it's a very important part of our IoT offering. And Greengrass is a piece of software that you will be able to deploy onto your objects locally. So once you've done that, what you will get is a local MQTT broker. So all your sensor can still use MQTT to communicate. And you will also get a runtime environment for Lambda functions. So that means that you will be able to process data at the edge. And by edge, we mean onto your devices or onto gateway very close to your devices. So what are the benefits of that? Why would you do that? First, if you can process the data locally, it means that you can act much faster on it. You don't have to wait for going back to the cloud, so you can save a round trip and act on the data as soon as you receive it. So first, for use cases where you need really strong performance, that's the way to go. The second thing is that for economical reason, you might want to filter the data before sending it to the cloud. It can be costly to send all your data to the cloud. Remember, it's IoT, so you will have to use connectivity on your device. That can be 3G, 4G, LoRa. We have all kinds of partners, telecom providers, but you will still have to pay to send this data somehow. So if you have a temperature sensor that is pushing the temperature every second, it's good because thanks to Lambda locally, you can still act on it. But maybe your machine learning algorithm on the cloud just need a data point every minute or every 10 minutes. So you can lower the volume of data that you will be sending. And the last piece that is very important is that you will be able to function even without internet connectivity. So Tom will give you a demonstration of that later on. Everything is working locally. You have your broker locally. If you don't have an internet connection, everything still functions. And as soon as you get back the connection, everything will be synchronized. In particular, the device state, if you're using Shadow locally with local storage, every modification that you have done will be synchronized with the Shadow on the AWS IoT side. And last but not least, I'm a developer. I'm sure there are plenty of developers in the room. You're using Lambda locally. So it's the same programming model that you're used to. You can still continue to use your tool. You don't have to learn something more. You can still code on the cloud. And once you have done that, we'll give you the ability to just push the configuration locally to your devices. So that's very useful. The second pattern we wanted to talk about is one when you have connected objects that are using for recording, streaming audio and video. So for example, think a house surveillance camera, drones equipped with camera as well, and also objects that will have to manage heavy assets. So yesterday during the State of the Union, we had Philips on stage. think about an MRI machine. Those generate images that are very, very large. It can be multiple terabytes of data. So of course, you will not send like that in one block, but still, that's a lot of data to deal with, right? So to work with that constraint, what we've seen customer using, and again, we saw a video on that that Tom and me could present. You can use MQTT for the control channel, meaning to give order to your device or retrieve the telemetry. It's very good for that because it will be very fast, very lightweight. And then you use whatever protocol is relevant to your use case. So if it's just sending, a small audio file, I can push that to S3 directly using HTTP, for example. If I want to stream video, I can use a streaming server. But whatever you want to use, maybe there are other protocols out there. The point is that you still keep the connection with AWS IoT to control everything, and then whatever is relevant to your use case as the data channel. The last one is very popular. It's using voice to control your objects. You have seen the announcement, I believe, in the keynote. We have a lot of services now in that space. And a lot of people are asking, can I control my object with my voice? Because, it's a very natural interface. And to go a little bit deeper into that one, we'll go through the demo. And it's called Amazon Lightshow. And it's a serverless demo. So what you will get, I will give you an URL. You will take out your smartphone, go there, and you will load a web page. This web page is on S3. There's CloudFront behind, in front of it. And then you will use the JavaScript SDK onto that page to connect to AWS IoT. There are 3 ways to connect to AWS IoT today: MQTT, HTTP, and MQTT over WebSockets. And that's what we are going to use in this demo. So as soon as you will load the page, you will be connected to the broker, AWS IoT, which means that you can receive data, but also send data. And your phone will send data. It will send the position, the OS you're using, and a timestamp. All the code is public. You will have the URL. So if you're curious about the demo, you can just go there. And you can see that the only information that is standing is this. On the other side, I will have the same setup, just that I have the UI for the administration of the demo. And all the data collected will be sent to Elasticsearch, Amazon Elasticsearch, so we can visualize in real time what's happening. So we'll see you guys, getting connected to the service and pushing out data. The last piece is using Amazon Echo. So here I will be using a simulator and AWS Lambda as a skill. So I have created the Lightshow skill, and I'm using Lambda to interact with the shadow on the AWS IoT side, and then give order to the smartphones. If you're interested in knowing more, there's an article on how to do this. There is code as well, so it's very easy to replicate. So come on, take out your smartphone now. It's your turn. I ask you to participate. You can go to that URL, so http://amzn.to/2e, capital B, E3, X, and W. So if you can push the luminosity on your smartphone, it is great. You will see why later. If you're connected through Wi-Fi or cellular, it's good. Keep it like this. If you can, turn the sound on your phone, because we're going to do something new. Instead of having the sound coming from the laptop, we'll be actually using your smartphones to produce sound. So push the volume up. And then it might ask you to share your location, so please do so we can see you on the map. So I will switch to the administrator interface. You will still have the link on there, so just bear with me a moment. All right, and I'm doing the same as you. So here you have the link that is used. 57 of you are connected, and I'm going to zoom in. All right. Okay. So most of you are in Las Vegas, and for some reason, some people are in Phoenix and San Francisco. Maybe they're using VPN connection, I don't know. All right, there's 80 of you, so we'll wait just a little bit more. During that time, I will log into the simulator to be able to give comments to the demo. All right. And now we'll use the sound on my laptop a little bit, just to launch this. Launch light show. Could you push up the volume on the laptop, please? Let me know when it's on. All right. All right. So there seems to be a little bit issue with that. In the meantime, so most of you are already connected. If you take a look at your smartphone now, you should see that the light is changing, right? So I'm using the shadow there to just change the light, and this should happen in real time, right? Okay. So now I'm going to use, is it working? So you've seen that everything is changing in real time. Now I'm going to use the voice to actually command what is happening with AWS IoT. Launch light show. All right, let's try one more. Launch light show.
Hello, everyone. I hope you are having an amazing reInvent. I can't wait to go dancing tonight with Martin Garrix. It is going to be so much fun.
Okay, so apparently Alexa can dance. I didn't know that. All right, and now let's give it a command. So, okay, everyone is almost connected, and you can see the split between iOS and Android. I'm actually going to film you to see this in the room, so please just turn your smartphone screen towards me. Ask light show to show device information. Right.
Everyone, please show your smartphone screens to the presenter.
Very good. So now if you take a look at your smartphone, you're going to see that it changed color, and you can actually see in real time, using your screens, what the ratio is in real life. And let's do one more just to warm you up for tonight's replay party. Ask light show to start the concert.
Put your hands in the air and move your smartphones.
All right, so I hope that got you excited for the party tonight. Thank you so much for participation. And so with that, we'll welcome back on stage Tom and Mick so they can talk to you about what it means IoT for them.
So we're making you do a lot of work. We're going to make you do work again. Keep your smartphones out. Please turn them to airplane mode. The reason for that is going to become obvious. We're going to show a little rover. The rover is designed for home use, small schools, things like that, so it's very sensitive to Wi-Fi. It's not used to 32,000 people using Wi-Fi on 2 devices at the same time. So wanted to just ask first, how many people work for a company with more than 1,000 people in here? Let me see. It's the majority of you, okay. So then you work in an enterprise. And when we think about IoT, we tend to think about IoT as the connected living room, home, Nest thermometers, things like that. How does that apply to an enterprise? That's what I want to talk about. I want to talk about how do we use it in enterprise, and then we're going to really flip it and take our little rover for a test drive. So we work at JPL. We are an enterprise. We're about 5,000 people. And I'm Tom Soderstrom. I'm the Chief Technology and Innovation Officer for IT and a long-term cloud user. We are working for NASA. So NASA is an even bigger enterprise. And we also work with the world, and the world is a pretty large enterprise. Not large enough In fact, what we're trying to do is to not change slides. Let me do it manually.
It's going on the other computer.
Alexa, change slides. Okay. Thank you. So we work in space, and so we are looking at several of the big questions. You can just show them all. These are questions that affect humanity, and the real thing that thrills us is that there's new technology, there's new capabilities to finally get these answers, and there's new collaborators. There's you all, and there is the children, the explorers of the future. So these are that's kind of what we do, and IoT has everything to do with that because it can make the people who make these things happen much more productive. Go to the next slide. So what we do is we prototype everything, and you're going to see the little rover prototype in a second. But the idea is, can you take consumer technology and use it in the enterprise? Can you use consumer behavior and use it in enterprise? And can you make it effective? If you can, it's really cheap, and it's really effective. It's hard to do, and you only learn by prototyping. So we're going to prototype and show some demos that we are working on. Next slide. I haven't said next slide for so long. That's like using those plastic things we used to put on overheads for you who are old enough. So what we look at is what's worth prototyping, especially in an enterprise. This is what we think it is. It's the human behavior. So it's if you look at this slide and you don't recognize yourself, I am dead wrong. So hopefully these are the things that matters. Who's going to do the work? It's the intrapreneurs in your enterprise, different crowdsourcing. For us, whoever thought that we would get our key infrastructure from a bookseller? It's amazing. And on and on and on. So it's different partners. Open, agile, prototyping, it's becoming the new way of working. By the time we put a rover onto Mars, it's a $2.5 billion mission. You don't want to be prototyping at that time, but getting there, that's much, much faster. And we can't outthink ourselves, we can't think of everything, but by just trying things, we learn. So, and of course, you'll see there a couple of things. You'll see Internet of Things. So that's one of the things we're prototyping. And conversation UI, and we're going to use that too. Conversation as a platform is a really key thing because we all talk. It's a whole lot easier. It's a whole lot more natural. So can we have a hands-free environment? Can we be in a clean room and just say, turn the tolerance up, turn the tolerance down, have Alexa warn us we're too close to an instrument, the cell phone is radiating too much, things like that. So is there really a difference between a connected living room and a connected conference room? We think not. It's in how we approach it. So if we go to the next slide. So what we look at is the innovations are happening in consumer space, and everybody who works has a smartphone, as we just saw, thank you very much, and wants to use it to do the work, and that's possible. So the next slide, the disruption of the enterprise, next, it leads us to think about how do we prototype this. So we came up with a strategy called Efore, which is engage and enable everyone and everything. And the idea here is that that's what we focus on for the next 3 years, and we're 1 year into it, so that we can see does it matter. Engage, and engage is kind of social networking inside the enterprise. Enable is everything that we're talking about IoT. It's open source, it's agile, it's crowdsourcing. Everyone is obvious, it's not just JPL, it's everyone. And then everything is IoT. Next slide. So now IoT Hype. Is there any IoT Hype? Yes. And is it a good thing? Hell yes. It's a really good thing because that means there is venture capital flowing, there's interest. And we don't have to invent it. We just have to figure out how to use it. And how do you take advantage of IoT? This is an eye chart, but imagine how many combinations you can make out of this. So it's not about inventing new technology, it's about using it in new ways. And that's where the prototyping comes from. So that's what we're going to talk about. Next. So the first of JPL's IoT use cases, so this is really enterprise focus, the conference room. How many people have gone into a conference room and spent the first 15 minutes trying to get the equipment working or doing a video conference? Raise your hand. Yes. Is it frustrating? So what happens is you said, to heck with it, and you just use the phone again, and you lose all of that collaboration capability. It's just too hard to use, especially in the pressure situation. So there's a lot of opportunity there. Next slide. Situational awareness. I think Andy said it really well, but if you can figure out all the things and what you do with them and you have it under your control, we can do amazing things. We can answer those big questions. Next slide. So IoT, but IoT, we think through everything. We try with lots of risks when you land on a foreign planet. But we can't be connected to the internet. We have robots climbing under the ice sheet, going into mines. We can't be connected to the internet because there is no internet. So we got to figure out a way of doing that. So green grass for us is a tremendous thing. It's really exciting. So we're going to show that in a second. So conference in the future. The problems is at JPL, work is good right now. We're getting a lot of missions, a lot of things. We have a lot of people, not enough physical space. So we're bursting at the seams. How do we deal with that? The wasted time to set up the room, schedules are not respected. The conference room, people schedule it and don't show up. And all of a sudden, people are complaining we don't have enough conference rooms. Can we detect that? So how are we going to solve that? This is Mick Cox. Mick Cox is an IT data scientist at JPL. And we just found out a wonderful preschool playground leader. You guys did great.
Thanks, Tom.
Good game.
So one of the ways that we might actually play at solving some of these problems with the IoT devices that are out there now, and especially looking at Alexa, is can you just talk to the room to get it to do what you want it to do, right? If somebody's frustrated and they're working on their computer, a lot of times you'll hear them say, just blah, 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 and like out loud. It would be nice if that was actually picked up and something happened, right? Or that was even the first way of interacting with your computation. In addition to the talking to it, we should be able to do something just as simple as touching a button and having multiple things happen. We've got some of these devices in our conference rooms that have, the touch screens, and they've got the list of projector inputs and then the list of the lights and the whole thing. You have to have a PhD to run one of these things in and of yourself, which I don't. And so we were hoping to have a more, simple way. So as Tom mentioned, we support many missions at JPL. And historically, what we've done to support those missions is stand up, each mission wants their own hardware stack, and a lot of missions want their own infrastructure physically, as far as conference rooms and meeting places go. And so we'll have some different support rooms for different missions. And so these conference rooms oftentimes will sit empty for a large percentage of the time. And what we'd rather do is to consolidate into a more intelligent space, but still without, we still need to be able to support the very different use cases of those different missions. So if somebody can walk into a room and say, conference room, Alexa, configure this room for my MSL daily meeting or my SWOT planning meeting, right? And the projector changes the input, the lights go to the correct setting, you have, the correct agenda up, and all of that kind of thing would be fantastic. Another piece that we're really interested in is the device detection, and the ability to kind of compare that against your schedule. And so, as you are probably aware, when somebody books a room in Outlook or whatever calendar system you use, it's not always used, directly to that 1 hour block. And sometimes they book it, don't use it. It's a recurring meeting, and nobody's ever in there, or people don't book it and they go and they use it anyways. So, is there a way that we can answer the question of who's actually using which rooms with IoT devices? At JPL, we've starting to put motion sensors with, kind of a little Raspberry Pi with a motion sensor on it, kind of like a $70, $80 price point, into some of these conference rooms to try and actually get real-time data as to who's actually using the different conference rooms and cross-reference that against our scheduling system to see which ones are actually being underutilized and which ones we might be able to consolidate on. And that plays again then in towards the Alexa and the real-time room suggestions. So if you're in a room, somebody else has it booked or whatever it is, you get kicked out and you say, well, what's the next room that's available? The room should be able to tell you what the next room is that's available.
As an example of that, I was being told we have to build a new conference room. I said, that doesn't make sense. I go in there, there's nobody in there. So we took one of these $80 motion sensor Raspberry Pis, put it in the ceiling, just measured it for 3 months, and then beat it against our scheduling system and found that it was not used 30% of the time it was scheduled. So you can now all of a sudden collect all that data and use the data instead of anecdotes. And that's really key. So what we're trying to do with these prototypes is just tell you these are things we're doing. It may work for you, but all of them are really inexpensive and really easy to do. So here's one example. Our partner, Leidos, manages our help desk, and we're partnering on the conference room of the future. So this is one example. When we do it, it's somebody with an iPhone or an Android videotaping somebody else playing with it. We're not professional videographers or anything, so forgive the quality of that. It's about demonstrating the story.
And there we go. So now Alexa has turned it on, set it to our resident computer in this conference room. But if I need Alexa to do something different, for instance, go to our Apple TV, Alexa, turn on Apple TV.
Okay.
And she sends the correct commands to switch this over to the Apple TV to enable us for AirPlay connectivity, or if we need to present something here. In addition to being able to switch between the correct inputs, turn off the lights, we can also set this room back to as it was before when we're all done. Alexa, turn off AV.
Okay.
And you'll see that she turns off the projector and turns right back on the lights with all this interaction.
So I talked about intrapreneurs. Kevin is using Harmony control at home. Does anybody have a Harmony remote control? So what's the difference using it at home to do exactly this in the conference room? Turns out nothing. So I just asked him, okay, record a video because we're going to show it. So he brought it in and did it at work, and now it's stuck. So those are the type of ideas. That's another example.
I'll kill the audio here. As another example, we want to try and collect the most accurate and useful information from our conference rooms that is possible and make it searchable and interactive in different ways. So one of the things that we did is we're kind of experimenting with 360 photography and videography to see if that gives us any sort of additional information about the rooms. So for a few of the rooms, this is a floor plan of Tom's floor at JPL, and that's Tom and his beautiful face and his beautiful office.
Very clean.
Very clean. So you can interact with the space if it's necessary, and because we have the metadata of which rooms are linked to which rooms, you can walk around and kind of take a little tour of Tom's office. See our beautiful Pasadena area there. In addition to this, so this of course applies not only to conference rooms but to any room. So if you, because we have the metadata and it's linked to directories in the back end, so we can search, where's Tom Soderstrom's room? We can show it on a floor plan, which was brought in from just SVG. From PDFs and created with SVG graphics. This one, we've installed some motion sensors, as I was detecting, in these conference rooms. So this is the conference room that I've installed a motion sensor in. If we go here and we filter out and we only show the motion sensor data for those rooms, then you can actually see up-to-date data for who's actually been moving in those rooms. So you can see that it's sat empty for the block from noon to 4 or whatever it is, so you might be able to use that room more efficiently during that time. Of course, we're also filtering on a bunch of other things, so we're tying in a lot of directory information to these floor plans, right? So now you can make it more interactive. You can break down the different spaces by the type of space. So some of these places are labs, color code it by available space, what's not available, so you can quickly search and find available space that way.
The other thing that happens with these things is IT and facilities loved each other, hate each other. IT says, I want to build this. Facility says, I want to knock out the wall. This simple tool that Mick just showed made facilities into heroes. All of a sudden, they're showing it off, and they can now measure the space and look at it, and it just generates this idea of playing with Internet of Things and doing more things. Now, how many people work in a place that there are no windows in buildings? Okay, not too many.
First off, we're sorry.
So you all have windows. Wow. Many buildings, especially in government, have no windows inside. So what could you do? You could put in a fake window. So what we did is take a leftover display, a couple of Raspberry Pi with it, and video feeds, and now dress it up as a window, and people have a window. So it will look something like this. On the right side, top right side, is our clean room, so you can participate and see what's going on in real time. It's a video feed. Below there is a view out of my office, so people can see, is it raining, is it dark yet? And on the top left is the beach. Why not? What are you going to do this weekend? So the idea is it's just Raspberry Pis and leftover displays. And what we do is we do that, show it for a little bit, then we take it away. And if nobody cares, then we don't put it back up again. If they care, we can now go deeper. So what does the architecture look like?
So just as Michael was mentioning before with that control plane and then the data plane, you can imagine at JPL there are occasional times when we're working on things where we don't want the video feed to go outside of our network, right? We have to keep it inside. We can't stream it through something like AWS IoT. So what we wound up creating, it's a very similar slide to what Michael showed, but in our case, we have a Raspberry Pi connected to the HDTV, which is communicating both directly inside to the actual IP cameras, which are on our internal network, and then also outside to the control plane, which sits in AWS IoT and Lambda, as well as API Gateway. So the only thing that winds up happening in the public cloud with this setup is the information of, okay, I need this JPL view, this Raspberry Pi, to switch to input 4. right? And so that's the only thing that's going through the external cloud. It picks that up internally and says, okay, I got to switch to input 4, which means this IP inside, and then it goes and it grabs that actual IP camera. So that's how we've kind of separated the networks and the sensitivity that way.
So that was one use case. Now, what about situational awareness? What we really want to do is be able to have all the data at our fingertips. So, for instance, view the most important metrics. One interesting one was we took all the trouble tickets, we fed them into Watson, and it came back, and Alexa spoke them. So you can come in and you can find out what are the 5 top IT security issues overnight. So things like that are very powerful. You can just listen to them, and you can, at home or in the car or coming in. You can be alerted very effectively, and we're going to show an example of that. And then you make sense of the data by using multiple senses. So if you imagine an architecture that has all the data in the middle, a big data lake, it has all the devices on the outside, whether it be a keyboard or smart glasses, smartphone, smartwatch, and then you have APIs into them. Once you've done one, you can do an API into all the others. But that's really what we're talking about here, and use as many senses at the same time as possible. And you know what? It's easy to do, and it's cheap. And that's what IoT enables us to do.
And IoT, really does help with that, as Tom was saying. So to use all of your senses, you're not just looking at your data anymore on a screen. You're actually potentially even hearing it. We're starting to get to the point where you can start thinking about things. You're touching the data and interacting with it that way. More efficient alerts. This has always been a problem in the enterprise space and even in your personal life because throughout the day you're going to get inundated with all sorts of normal stuff, right? At the beginning, like the pager was the greatest thing ever because it was right there and it alerted you of something. Then that became kind of old, and then email was like the next best thing. Then all of a sudden email, you get 1,000 emails, then it was push notifications. Push notifications are great because it's the most important stuff that pops up right in my pocket. But now you get 1,000 push notifications. What is the next thing that could give you the most kind of up-to-date and real insight into a very complicated system without getting lost in the noise, making that much more efficient, that whole process, and it makes it much more natural for people to be able to interact with those types of systems.
So we're going to show an example. We hired a professional actor, see if you can figure out who it is. And just to show an example, one of our most important use cases is cybersecurity. So how do we find out where lots and lots and lots, millions of times a day, attempts are attempted. So let's see if you can figure out who this is.
Of things and immersive analytics, this concept we've come up with to enhance our cybersecurity awareness at JPL. For instance, we have data coming in off of our firewall in real time about where the attacks are coming from, where the traffic is coming from, and using analytics we can decide what's normal, what's abnormal. For instance, we can assign a note on the piano keyboard to each country that traffic is coming in from with representative data and actually listen to your firewall. You can hear when it speeds up, you can hear when it slows down, you can be navigating away at other pages and still be getting insights in real time as to the state of your firewall. Another thing that we can do is use consumer devices, smart light bulbs that change colors programmatically or with your phone, so that we can actually look at, for instance, how much traffic is being blocked or let in, and we can actually update the colors of the lights in the room in real time based on our firewall. If I make it some representative random data, you can see, of course, watching the colors of the room change in real time. This is also very powerful because if I'm doing normal work or something else and the colors of the lights in the room change, this is a very obvious indicator that something has occurred and I need to take action.
And those lights are all over JPL. So now what happens is the cybersecurity group gets notified. They don't have to be looking at it. They know something is wrong. And they can now say to Alexa to change the light color to either security normal, elevated, or alert. So it's all of that. And by just prototyping, we understood that. So what does the architecture for that look like, Nick?
I want to just take a moment to talk about that because this was sort of counterintuitive that I could walk into our cybersecurity operations center and say to them, hey, I have an IoT solution that's going to make cybersecurity better. Right? They're going to look at me like I'm crazy.
That went over really well.
Yeah, they laughed me out of the room. So the way that we kind of convinced them that it was okay and that might help is we created a different network entirely from our internal network. So all the internal network, everything runs internally, all the crown jewels. We don't want to just be putting random or new emerging outside devices on our internal network. In case there are vulnerabilities, they could get hacked, somebody gets access to the network that we don't want. So what we wound up doing is creating a devices network that's exclusively for these new kind of prototype-y, whatever, we don't know who they're talking to, but we don't care kind of devices, that we can just give them access to the public internet and no access, so it's completely air-gapped between that network and our actual internal network. So now how do you get the information out from the systems that you care about to communicate with your IoT devices, right? So one of the ways that we've worked around that, just very briefly, a quick overview. For example, if I have an Alexa skill that I want to query our internal acronyms database. We've got like 4,000 acronyms in a database, and what the acronym is and what it actually stands for. So I would ask Alexa, she runs her Lambda function, which publishes a message to AWS IoT, which says, hey, I have this Echo device, which is asking this question. That gets picked up from something that's inside, running internally, which has access to all the databases. That service runs the query, prepares the answer, and then ships it back through IoT, goes back to Lambda, which goes back out to the Echo, and then we get our answer kind of that way.
One of the key ways of doing it, one of the key benefits by doing it this way, where we have a network that we don't trust, we don't really care if the devices are trying to hack each other because they're not getting into JPL, is we can now evolve much faster. We're not afraid of putting new devices on. In fact, we created also an incubation network where we put things on, new devices, to make sure they don't report home, wherever home may be. Those things are easy to do, but you engage the network people and the cybersecurity people, and now we can really start experimenting. The last use case before we show the demo, and we'll go over this quickly, is IoT Without the Cloud, Greengrass, and we're going to be demonstrating that. So really, it's for us, data regulation is a big deal. We all have various regulations. We have something called International Traffic in Arms regulations that we have to adhere to. So we use Amazon's GovCloud for that, but even some other things we can't use, we have to have inside. So we don't always have access to the internet, especially when we talk about rovers, so we're going to see that in a second. Network cost and latency is fairly obvious, especially if you're climbing underneath an ice sheet. You can't really have much latency. And then making sense of the data is, in an ideal world, so we have our robot, for example, since we're going to see one, it knows what to do, and now it also has internet to the huge brain that's the internet. It has access to that. And then now we get the best of both worlds, local and analytics when we need it, and artificial intelligence. So the benefits here is that it's the same programming model. People don't have to be specialized in one or another. We can have our engineers and scientists actually program the rovers themselves. Yeah, I think it's seeing is believing.
Seeing
so as you see this,
believing.
one key thing. This is a toy. It's our ambassador to schools, kids, middle schools, high schools, students, and museums, to get people excited about space and that they can build their own robot. It's built from open source software and Arduinos, Raspberry Pis, things you can get off the shelf. And we're happy to share the blueprint. In fact, we want to. And then it has open source software on it, but it also has AWS, Lambda, IoT, Lex, and Greengrass, and probably something that I'm forgetting. But today's toy is tomorrow's tool, sometimes. And is this the one that's going to be a tool? So let's you behave now, Rovi.
So as Tom mentioned, we're playing with a lot of new services that were announced this week. Two of the big ones are AWS Greengrass and Amazon Lex. Some of the things that we were able to do with Greengrass and Lex was give this robot new capabilities that she's never had before. So for instance, she can answer questions about Mars. Rovi, how big is Mars?
Mars is about half the size of Earth. Its land area is about that of all of Earth's continents put together.
Rovi, what is the radius of Mars?
The average radius, distance from its center to its surface, of Mars is 2,107 miles, 3,390 kilometers.
So, but Rovi can do more than just answer questions about Mars, right? So we have a database of about 1,000 questions that people on the internet have been asking about Mars, the most common questions. We actually made a publicly released Alexa skill. It's called NASA Mars. Tom announced it on Tuesday night. So if you want to go home and check out the NASA Mars Alexa skill, download it. You can get all of the same answers that she'll give you here, as well as updates with what the actual rover did on Curiosity today. So definitely check that out if you're interested. But like I said, she can do more than just answer questions, right? You can also give her drive commands. Rovi, follow me.
Following.
So she has a 3D sensor on the body, and she watches where I walk and will follow me. So you can actually see on the screen as well in real time, that will be updated with the path that she is taking. So what's happening here is on board, that 3D sensor is publishing messages to AWS IoT. Once those messages hit the cloud, they're subscribed to by the head and by the wheels, and that causes the wheels to turn. And she can tell I didn't shower this morning, so she backs off when I get too close. You can see it update in real time again. I'll just walk her around a little bit more, send her this way, point her straight. So now you can imagine, oh, she sees that speaker.
She fell in love with the speaker.
What you doing there, girl? All the rovers have always had a history of being very curious. That's why one of them is called Curiosity.
Ooh.
Yeah, sorry, that's too bad.
If you don't know, Curiosity is the current rover on the line.
Just make sure she doesn't see anything over there. So you can imagine with the typical AWS IoT setup, if this rover were to lose connection to the internet, all of that's going to stop working because the wheels will never get the messages back anymore. Today, all the devices that are on Rovi are connected to the public internet through this router. And this is the public internet connection. So I'm actually going to yank the public internet connection. So Rovi no longer has access to the outside internet. So with a typical AWS IoT setup, it would not continue to work. But because this is running on AWS Greengrass, it will still work as planned. So the sensor is still seeing me, still publishing messages locally this time instead of to the public cloud, which are still getting picked up by the head and by the wheels. So I'll drive her around a little bit more. Drive her this way. Drive her this way. Now, one thing to notice here is that nothing's updating on the app. That's because the app is running on my laptop, which only has access to the outside internet. It's not connected via the router. So these messages are not going out to the outside internet right now. But if we collect a bunch of data offline, we don't want to lose access to that when the robot gets internet connectivity again. So let me demonstrate what happens when that happens. I will give her back her internet. So this will take a couple seconds to connect to the public internet. Once that happens, this will take a couple seconds to reconnect all the devices to the router. But in the offline mode, Rovi has been spooling up everything that's happening, and as soon as it connects to the outside world again, you'll see the entire update on screen, which just happened. Did it just happen? Did it also? Yeah, okay, there we go. Whew.
So as he flips up the architecture, just think about this for a second. What about people stuck in a mine? Can the rover go in, find them, lose connection to the internet, and then back out, upload and get connection to artificial intelligence, take a new track and get in all by itself? And that's where today's toy is tomorrow's tool, and we think this is really important.
That's absolutely right. And with that, I think we're going to open it up to a little bit of questions. We have about 10, 11 minutes left, so I'll invite Michael back up on the stage. Thank you very much for your time, and feel free to stick around for questions. Actually, we can take questions from the stage, too, yeah. But thank you.